Let's see. All right. One sec. Okay, cool. And yeah, I think got my whole screen about as maxed up as it can be.
Mm-hmm.
Okay, cool. So one of the things that I had discovered for my class is that we use streaming like Google Hangouts on air per suggestion of Charity. Jeff, do you guys record your lectures?
Which lectures?
Your
class lectures.
Your class lectures. Yeah, Jermaine's.
No, we don't. I mean, no.
Yeah, we've started doing, because we're kind of trying to do like joint between the online and on-campus classes. So we actually stream them live. And we should get about like 15 or 20 on-campus online students in addition to the on-campus students. And then they can watch it recorded. But yeah, we use Hangouts on Air. Everything's auto, like stored and private linked and all that stuff. So no recording.
Yeah, currently we're not in a room that has the equipment for that. So I'm not sure if that. You must be in a room that has the video equipment now.
No, we just record just like it's just the computer, so it's just the screens and the voice. Yeah.
So we might switch this to that, is what you're suggesting.
Well, it might be easier just for the recording.
Yeah, it probably would be.
It's like Hangouts is a little weird though, but there is a way actually to put this inside a Hangout, like WebEx inside a Hangout.
Very meta.
Very meta.
Yeah. Right.
Anyway, thanks for noticing. So today is going to be a discussion that kind of intersects some of the, maybe we go back and forth between more engineering-oriented discussions and more sort of data science-oriented discussions. And so today is going to be one that's going to be a little bit more around some of the engineering pieces. But I think hopefully by the end you'll see how very complementary. And I will ask briefly of Christine or someone who knows, is there a way to do a full screen notebook, or it just kind of probably not
right now?
Oh, I just didn't know if like notebooks had a full screen like keyboard shortcut.
Do you have any?
I just didn't know if that was
I don't know if there's.
I've never had a need to do that.
You can toggle the header like it showed there. I forget what the key.
Oh, really?
You can toggle the header and toggle the toolbar.
Oh, cool. All right.
Go back to view.
That's the thing. Okay. Oh yeah, toggle header. And thank you so much. Toggle toolbar. Awesome. Okay, great. So we will jump in. So the goal of today, in terms of our discussion, is a focus around the integration of ClarityNLP with the rapidly emerging healthcare standard HL7 FHIR. So specifically, we'll be talking about how to combine FHIR APIs with the ClarityNLP framework. And we're going to focus on three components and then pull them all together. Those three components are something called FHIR, Smart on FHIR, and the ClarityNLP as a service stack. And as usual with our presentations, there's documentation on how to actually install and use ClarityNLP in our documentation on GitHub, on Read the Docs, as well as in GitHub. And we welcome you to join our Slack as well, and I'll probably add to, by the end of this, the Slack link to join our Slack. So the first piece of this is around FHIR. So for those of you that are not familiar, FHIR, HL7's Fast Healthcare Interoperability Resources. I learned yesterday it used to be like Fast Health Interoperable Resource back in the early days, but they have now settled on the acronym standing for Fast Healthcare Interoperability Resources, and it's a data communication standards based on RESTful APIs. So a little bit about FHIR to walk you through. So it's a pretty big shift actually in the way that health systems move data, and it really opens up a huge opportunity for integrating third-party applications into the clinical environment. So I'm going to just take you through a little bit of a mini presentation, and on a meta level, I learned how to embed Google Sheets into
getting more and more meta
into Jupyter.
So meta, John.
Yeah, just to do it, right? Just to do it. But so we can talk a little bit about FHIR without having to copy it all into a Jupyter. So FHIR, first off, is a messaging standard used in healthcare. As mentioned, it has this pretty awesome logo that you'll see around. So the deal with messaging standards, there's been a few main ones that have come out of HL7, which is kind of the international body for this healthcare messaging. The first one was HL7 version 2, starting back in 1987. Then version 3 started in 95 and kind of lasted to the early 2000s. And we'll talk about why that kind of went. And then they started something called a fresh look in 2011, which emerged and evolved into something called FHIR, formally in 2014 with the first release. We're now on the 4th release of FHIR. So HL7 version 2 were, believe it or not, these pipe delimited documents. They didn't have a lot of space to work with.
I remember those.
Things were at a premium. And HL7 version 2, not only are they memorable, but they're still actively in use. And I would say HL7 version 2 is used more than any other healthcare standard still today. So this came out again in the 1980s, and it is still the #1 way that they move data from labs to hospitals, between healthcare systems. I mean, it's still heavily in use, particularly in laboratory data. But it looks like this, and it's got these little crazy components that basically refer to what section, and you can see in here there's like blood counts and leukocytes and hemoglobins, and they do all of this in a pipe-delimited format that meets the sort of recipient's expectations, so it works. HL7 version 3 is based on XML documents. It made a lot of sense. I took out the slide showing, because it was simply literally too large for this screen, showing the full data model behind HL7 version 3, but it is massive and massively complex. And it turned out not to get a lot of traction. People were somewhat loath to move from version 2, though it has been adopted for CDAs or CCVs, so basically like a summary document. And it is the standard way that many health information exchanges will move kind of the overall patient record around through these CDAs or CCVs. So those were also XML documents. Then beginning around 2012, as mentioned, they started saying, well, shooting around these documents seems kind of cumbersome, and we're not getting the traction on version 3 that we hoped. So can we rethink the approach to doing this? And so HL7 FHIR brought the introduction of an API-based approach, and more of a web-based approach. I think many or most people here know kind of about what this is, but the idea of a RESTful API is sort of this idea that you use standard HTTP methods or standard web methods to move data around. So you might have some kind of application, and it's basically sending some information and says, get, post, put, delete something, and then it goes to the database and does that. So a good example would be in somewhat of a kind of classic RESTful style that you might do, like get, whatever the server name is /movies, and it gives you all the movies. You could then say get movies with a particular ID, and it would find that particular movie. You could post to add or create a new movie. You could put to update a new movie or update an existing movie, and you could delete to delete an existing movie. So these kinds of things would then take some sort of body. You can, for those who are sort of SQL database type people, it's kind of like the CRUD kind of mapped over to HTTP. So RESTful has obviously been very successful, and it's how much of the web runs. And it was how HL7 thought we can get back in the game by updating healthcare data to this same model. So an example of some RESTful FHIR types of interface or examples would be something like, get, so this would be the, patient. If you just did patient, it would be a list of patients. If you do patient /123, we get all the data about patient 123. You might say, like, I want to get a particular encounter, or you might say, I want to update data about an encounter, in which case you might do a put, or I might retrieve a specific document. And so, as we'll see, you can include all kinds of different parameters, but the standard methods by which we use RESTful APIs have been mapped over into the healthcare domain. Now, there's a lot of healthcare, and this is an example of, get, / condition resource patient 29610. It's going to go back and it's going to get all the conditions for this individual patient that has that particular ID 29610. And this is one, but it's actually a bundle of maybe 30 or 40 or 50 conditions that match that patient. So it's an example. It's a pretty simple way to move data around compared to what we were doing previously. Really, with the previous versions, there wasn't really a way to request in the same kind of model for HL7 version 2 and version 3 quite as cleanly and specifically as you could do with FHIR. So these are some of the big categories of FHIR resources. You've got, for example, sorry, it's a little bit hard to read. You've got things like allergies, conditions, procedures. You've got things related to like care plans and overall goals of care. Then you've got a lot of stuff about medication. So medication itself could be a medication dispense event. It could be a prescribing event, an ordering event. Administration means giving it to the actual patient. And these little numbers next to it, 3, 3, 2, 0, 1, etc. Those are the levels of maturity along the FHIR standard for these. So some of these, like procedure, means it's at the third stage. It's fairly mature. N means it's a normative standard. It's now kind of locked in. But something that's like a 0, clinical impression, they're just kind of working through it. Even all these device elements are very new. So many of these have not gone through the full balloting, which can take many years of working groups. Now, this is the full list of FHIR resources. It's not designed so much for you to read through, but just to recognize that there are quite a few FHIR resources. And this was with a goal of actually being somewhat parsimonious in the selection of what's represented. This kind of idea that there'll be sort of an 80-20, like 80% of healthcare would be represented, they would kind of develop standards that would cover the majority, but the long tail of edge cases, which can often be, this sort of long tail representing a small amount of data, people could build extensions to. And so FHIR has a mechanism to build extensions, so you can create your own resources that can be used in your particular server, but not necessarily as standard across the board. We're going to focus in our world on this one little guy here, document reference. Document reference, stage 3, so pretty far along the way, and document reference is going to be what we're going to leverage in Clarity to make our NLP engine be able to integrate with the EMR. So this is what the document reference resource looks like. You can see here, it's sort of related to the other components, and this is the kind of scope and usage that it has, and it might be a little bit broader than you'd expect. So a document can be what we're kind of talking about today, which would be like patient. I don't know why they don't list here. So document. So like just electronic data about a patient. PDFs, digital records, scans can be elements, but text files itself, non-standard formats are also included. Image files are also considered types of documents at this point, and really any other kinds of recorded documents, but they can also be themselves those HL7 version 3 continuity of care documents or CDAs. They can be other FHIR documents. So basically documents that are really general. You can put almost anything under that category, which is, as you can imagine, healthcare systems are like, well, everything pretty much gets stuffed in as a document unless we can find a better place for it. So this is an example from the FHIR sandbox. Now, FHIR has a really awesome coding sandbox. If you go to code.cerner.com, and I just learned yesterday, because we had a speaker from FHIR come and give our Snow Day talk, that code stands for Cerner Open Developer Environment, and they've actually done a really good job documenting all of the different APIs that they support across the board, and they've got a pretty robust set of those APIs. Now, Cerner's sandbox, this would be the way that all of this first thing here is like a super long way of just being the name of the server. So I'm assigned a particular server or draft, as a user, but this is the main part. I say document reference, patient equals this. So document reference, patient equals, and I guess I can blow up a little bit here, see if it makes it bigger. Document reference, patient equals 1316024, created on this date, greater than this date, less than this date. So essentially what it's saying is go find the documents for this particular patient, 1316204 at this time. So this is what's returned. It's a bundle of documents, and it comes back, and what you can see in the Cerner implementation, and this is like kind of what results look like. Like here's a FHIR result, is it says here's the resource, document reference, here's the resource ID, and then it's got a little text that's generated in this particular case That's top level, and it gives you the subject information that matches our subject, gives you the patient's name, and it has a coding here. This coding refers to the type of document. If you went and you looked up this LOINC code, it would tell you that this is a rheumatology consult note. So they use the LOINC codes from the LOINC document ontology to specify, oh, I'm sorry, here it is. Rheumatology consultation. That is the type of resource that is being provided in the document reference result. And then it's created on the date where we're looking here, January 6, 2016. And then when you get down to it, it actually says the content is an attachment. It's type PDF. Oops. Remind me not to double click. It's type PDF, and it is located at this particular URL. So the way that things would work with Cerner then, if you had an application, you'd say, go out, get your resource for this patient using that query that we described above. It's going to return here 4 documents, and you're going to say, okay, good. Let me go down. I'm going to get this note. I'm going to get the attachment. I'm going to pull the PDF, sadly, and I'm going to then have that PDF to work with. This could be a Word document. This could be a text document. This could be a reference to just an electronic file. But essentially, this gives you the pointer to the location. Another mechanism by which data are shared using document reference would be how we use it in our OMOP on FHIR server. This is the same scenario, right? This is just our FHIR server, so no different from had it been Cerner. And this part is the same, right? So document reference patient 8940. In this case, we're not specifying a date, but we could have specified a date range. And we get back a bundle. This turns out to be a bundle of only 1 result. And you can see type is document reference. We've got the LOINC code here that says it's a discharge summary. We have the patient name. Yeah, it matches what we're looking for. It gives us the date on which it was created. And then in our particular case, our attachment is a type text plain, right? So it's not a PDF, but it is served up not as a pointer, but directly with the data in the actual response. Those data are base 64 encoded. So in some implementations of FHIR, rather than being a pointer to a link, you actually have the data come back as a result. So in our case, we've got the base 64 encoded version of the document in the body of the response, and you can then use that for NLP. So I'll pause there briefly to just ask, because I know not everybody here is sort of web developer, but is it fairly clear how one would obtain documents on a given patient using an API like FHIR?
Mm-hmm.
Okay. All right, so that is the existence of FHIR and being able to pull documents is the achievement of a lot of work, a lot of standards, but we happen to be in a time where things are evolving very rapidly and all the major systems, Cerner, Epic, and and all the major EMR systems support it, as well as some other research applications. So FHIR, being able to pull data as we just described, is there, exists, and we can use it today. But to make it easier to use, there's something called Smart on FHIR. So Smart on FHIR is an application framework for building FHIR-based applications that are seamlessly integrated into electronic medical record systems. They've got this cool logo. The origins of Smart, Charity may or may not recall this, but Smart was actually part of so it was a $15 million grant that went to Harvard because one of the professors at Harvard, Ken Mandel, who's one of the luminaries in the field, wrote an article or opinion editorial in the New England Journal of Medicine that said, it called an app store for healthcare. And it was just like, why don't we have an app store for healthcare? I mean, it was really just kind of like, hey, we need an app store. And it was hard to disagree with that notion. Everybody thought, well, that makes a lot of sense. And when ONC had some money to provide for funding, one of the things they said were like, yeah, we like your idea. And they came to wanting to build an app store, and they came to Regan Street, where Charity and I used to be. And they worked with a guy named Mike McCoy, and they began before FHIR had really emerged as a standard. And they said, we need to do this. And so we were working through different mechanisms of creating kind of that app store base. But as it became clear that FHIR was going to be sort of this dominant standard, it became merged as this notion of Smart on FHIR, and that has been really how Smart has worked since then. There's 2 big things that Smart provides. Number 1, an authentication layer to enable single sign-on from the EMR through to third-party applications, so that you can, as a provider, you can basically go in, So I'm logged into the EMR, and I can launch a FHIR app, or it can get launched, and I don't have to log in again or anything. Obviously, that's a big deal from a workflow perspective. But the second thing that it gives you is the context of the patient and the FHIR server from which this application was launched in order to streamline the retrieval of data by the web application. So the big deal is that the application can deal with functionality, but it doesn't need to know, it doesn't have to select patients, it doesn't have to configure the FHIR server. You don't have to build your app to say, like, you know, what's my FHIR server and what's my, you just have a like dollar FHIR server, and the smart environment says, I'm going to give you that, and I'm going to tell you who the patient is. And so you can just be like $patient, and it will take care of all of that. So you can build an application under the assumption that you will have the context, and you will have the patient of the FHIR server and the patient themselves, which is obviously a game changer if you're going to build this kind of application. It also gives you a simulated EMR environment, which we'll look at in just a sec. But basically, you can say, I want to launch my app, and I want to launch it like within an EHR interface. I want to launch it as a provider standalone app, as a patient standalone app. I want to launch it using this triggering mechanism called CDX hooks. I want to use certain FHIR versions. I want to simulate errors, all kinds of cool stuff that you might want to do if you're an application developer. And then it launches a little application. This is one that Eric Soto, we built for a mobile health device. So you could like link Fitbit and Google and stuff like that to your patient. So you can kind of see how like the outside we've picked the patient, and on the inside it knows like the name of the patient and so forth. It's connected to them. I won't get in really to the flow unless people are interested, but just to kind of have here in this Jupyter notebook, you know, essentially that the EHR launches it, and there's the metadata that goes back and forth, so that when the time you get to the application, it actually knows who the patient is, it has an access token, it has the FHIR server, it has the data, and it all kind of works behind the scenes. So if you're more interested in learning about SMART, you can do so via that mechanism. So there's a big note, a big NB, I don't know, we'll call it a caveat or just something good to know, but it's this, that FHIR applications are generally focused, so important I put R twice, are generally focused on individual patients, right? So that's due to the performance limitations of FHIR servers for bulk querying. It's not a great place to say, go find the 250,000 patients that match this condition over these dates by this condition, kind of stuff we do with Clarity in general, the kind of stuff we do with OMOP and Odyssey. That is not really what FHIR apps are typically built around. It's a big bulk of data if you're going to be looking across populations. You can do it, but it's definitely not something that is generally a target because, you know, it doesn't perform quickly. But FHIR apps are great for analyzing a particular patient, for extracting data about a patient, visualizing it, for delivering decision support, but not so much for population-level analytics. So, you know, more traditional ClarityNLP engine would be used for that, and we'll show a couple examples of that in just a second. So, before I move on, are there any questions about SMART on FHIR or why we would want to use some type of framework to wrap FHIR to build an application? All right. Basically makes sense. Okay, cool. All right, so the third part of the stool upon which Clarity on FHIR is built is NLP as a service. So that's basically the idea that in order to build an NLP application, you actually need an NLP engine. So here we use ClarityNLP, of course, because this is cooking with Clarity. But you could build a FHIR application using any other, you know, any text analytics APIs, really any APIs. But, you know, we've talked in previous cooking sessions about using Google, using Amazon, IBM, Microsoft. You know, you can use any of those services, and you could pull FHIR the same way you could feed it through in the same mechanism. The main thing is that you have to take the patient documents you pulled via FHIR, and you've got to be able to run an analysis that's relevant to the user. So what is Clarity NLP about, or ClarityNLP as a service? Well, it was designed to support use cases where a small number, relatively small number, of documents need to be analyzed, but without necessarily requiring the overhead of a full ClarityNLP installation. You can, of course, have both. But if you've been sort of tracking the ClarityNLP examples we've done in previous weeks, you'll know that we upload thousands or millions of documents, and we process queries across large populations. With ClarityNLP, you can run multiple jobs You can build upon previous analyses. And most importantly, you pass in the NLPQL, which defines the query logic of each job. So you can do some pretty clever custom stuff to find these populations. And here's an example of a typical post to ClarityNLP. So we've got a ClarityNLP server, we've got an endpoint, which is our NLPQL endpoint, and we've passed in this little instruction. And these instructions basically say, I've got a new phenotype called patient temperatures, or actually I guess it's maybe fever, and I'm going to pick a document set. I've created a report list here called nurse. I've created a term set called temperature terms, temperature T, and I'm now going to use the value extraction algorithm to say, take my terms, take my documents, find the values that match between 96 and 106 as being a typical temperature range, and those are the features I'd like you to take. Then take those features and return back the ones that have a value greater than 100 in this particular case. And that could be changed. So that is essentially a very typical way of how you might use NLPQL to build a query across a population. And if you run it, having specified the type of nursing note, specified the target, combine the value extraction process, your results would look something like this if we were looking in the UI as opposed to just downloading the data. You get sort of a list of people who match that, which, as you can imagine, are a list of people where the temperature values are greater than 100. And these matching events are going to be all the times where somebody met the criteria of having that temperature greater than 100, 100.4. What's nice, you can then drill in and say, okay, yeah, how is this patient matched? Well, this looks correct. The patient is indeed, here's the note, patient febrile, temp of 1015, temperature reduced to 100.7. You can see how both these patients match the criteria that were defined. In this one, I actually clicked at 100.4, and I can say, yeah, that looks good. So awesome to be able to do that and to be able to find populations and, of course, much more complex logic, thanks to the work of Richard and other folks here, to be able to build increasingly complex logic into your Clarity queries. In contrast to what we've just described above, NLP as a service is conceptually stateless in that you're not storing documents on the system, you're not uploading to a large database in advance where you're then running NLPQL. Rather, you're posting the documents that you want to analyze, and they're essentially synchronously processed and your results return. So you're not uploading everything, instead you're saying right at that time I'm posting it. Furthermore, and this is kind of another big difference, you actually don't need to create your own NLPQL, but rather you simply send your documents to an endpoint that specifies the analysis of interest. And we'll talk about the ways, the pro and cons here. But essentially, an example for exactly what we did before, a temperature extraction endpoint is provided on the server, and you can see how it can be used very, very simply. I'm basically posting to NLP, this is the URL, it's a job, general temperature extraction. So essentially what this is that there is an endpoint called temperature extraction, and all I'm doing is I'm posting my reports. So I'm just saying, take these and run the temperature extraction algorithm on them. And so what this will return is essentially the results behind the scenes of saying, yep, here's the sentence you sent in. This was sentence number 2. And this is what we found. There's a value of 102.5. The feature is called temperature. And so you basically can imagine that this thing is essentially going through, it's processing these strings, it's uploading them, it's processing, and then it's returning the results. And so this then turns Clarity into a service that can sort of work on the fly without having to have upload and stored. In fact, you don't need to have a ClarityNLP instance running at all in your environment in order to use this service. Now, if security is an issue, then you would need to have a secure framework around this in order to have the service run and be compliant with encryption and so forth. But in terms of needing to install something locally, it actually does not need to be installed locally in order to use this service, but you could. This is running the same process as what we did before, but instead of using nursing notes, it's using the notes that were sent in the post. And there's this clear difference then between NLPass, which basically is passing dynamic documents, at least in its present form, dynamic documents to static NLP endpoints, NLPQL endpoints, versus regular Clarity, where you're actually passing dynamic NLPQL is what you're posting, and it's passing it to static documents. You could probably imagine a university say, well, John, why can't I pass my NLPQL to NLPass? You could, and it could be done, but as the current instantiation, the endpoints are sort of fixed. You know what's going in and you know what's coming out, so we can document endpoints like temperature extraction in a way that can be reused by other applications. So how do you add new functionality to NLP as a service? Well, it turns out all of this is really just run by the GitHub repository. So we actually have a repository of NLPQLs, and those NLPQLs, the temperature extraction, is actually just represented as an NLPQL on the server. It's got a few little tweaks that make it different, but essentially it's the same stuff we had before. It's temperature terms, it's value extraction processes, it's temperature values, and it's represented the same way. At this point, we're not using dynamic variables. You probably are saying, well, 100.5, boy, wouldn't it be nice if I could configure that? Well, that kind of then is a little bit walking the line between what's NLP as a service versus what's not. But in our current implementation, you essentially create these endpoints, and you can create new and novel NLPQLs, and you can then bring them to into this repository. And as soon as you add a new NLPQL to this repository, it automatically rebuilds and relaunches the service so that you're now using the latest NLPQLs. So NLP as a service is flexible if you own the service endpoints, and you can modify, and you can change and add new elements. So that part may be a little bit more complicated, but everyone basically understand what NLP as a service is and how it relates to ClarityNLP main. Are there any thoughts about, so for simplicity, we made these endpoints, right? We made this notion of, you hit an endpoint like you would on another API where this gets temperature and this goes and pulls out a particular assertion. And it's actually handy to do that because it lets people, use these externally very simply. Does that make sense? Would it make sense to essentially have some variant which is also like the NLPQL endpoint where you pass the documents plus the NLPQL?
Potentially, although that kind of exposes more of a security risk.
It exposes more of a security risk, right? Yeah, because exactly. Unless the server was always empty. Yeah. Which is kind of how we modeled it in theory. That there would never be any persistent data.
I mean, this service is, if it was theoretically different and didn't have any data.
Right. It had no data, and it was.
And made sure, it has to have that clause where it can only operate on that set of documents that you post. Yeah. And even if it's not in the NLPQL,
you force those documents. Yeah, it only can happen with submitted documents. So anyway, food for thought. You can see there's a million ways to do things and ways that you could incorporate. But the goal was simplicity. But one could imagine having NLPQL or having variables in the NLP as a service mechanism. So we've talked about three parts: FHIR, Smart on FHIR, NLP as a service. So now let's look at let's launch the application and see how all of this works together. Now, what I'm doing here is I'm basically going out and I'm saying, I want to launch an EHR. I'm going to pretend I'm in an EHR. And I'm now going to select a patient. If I had already loaded up a patient, I could have, it would have brought me right to that patient context in here. I would not be selecting from this level. I would already be in the middle of a patient's run. So in this ClarityNLP FHIR client, this particular version that Charity put together, it basically lets us grab any of the NLP as a service endpoints and just say, yeah, go ahead and just run that endpoint. So this guy, Jeremy Bodyfelt, this app says he's got 12 documents. What it's actually already done, behind the scenes is it's gone and it's pulled Jeremy's 12 documents. It's got them ready to go, and it's now sending them off to the NLP QL server. So what's happening here is that I've got this job that just got passed along, and I'll see if I can move it up a little bit here. really making work for that thing here. And basically what they've done, what it's done, as you can see, is it's behind the scenes, it said, okay, go run that job on the NLP as a service server, ejection fractions, and I want you to pass in these reports. So this might look familiar to you. What you can imagine is that Charity has parsed the FHIR response. She went and got the documents from the document reference resource. She took care of the base 64 encoding, and then she basically put them in to the into the JSON format, which has been passed along here. Having done that, she's now run it, gotten the results back from the NLPQL server. I'm sorry, the NLP as a service server, and she's got all the features: ejection fraction, ejection fraction, ejection fraction. You can see there's one called low EF patient, and what we've done here is that you can see that he's got a bunch of EFs: 25, 60, 50, 50, 55, et cetera, but only one that meets the criteria, which I believe was less than 30%, which refers to this particular mention. So you can imagine that you could build the application to say, I only want to see results that meet certain criteria, etc. And that basically would allow you to specify, I only want to see the low EF patient data, or I only want certain elements. We could also have a very diverse set of elements. And I want to go back to the whole point of why we would do this and how this relates to Clarity. So if we had run in Clarity, we could have done this exact same low ejection fraction query, which is essentially what this is. And this is a low ejection fraction analysis. It runs at the population level. It goes and finds all the patients that match this particular set. So I think I was here. Yeah, and it's found all these patients, and basically all of these guys match this element. Where in the smart environment, we were on a particular patient, it found data about a particular patient's information and returns it. So why would you do this, and how might you utilize it more extensively going forward? Well, here's some things to think about, because there's many ways to leverage ClarityNLP with FHIR to create applications of interest, ranging from clinical, quality, safety, cost research. So here's some examples. So one could say, I want to use patient symptoms to look at medication side effects. So symptoms are typically not in diagnosis codes, but they're like in the review system. So you might say, I'm going to look at the patient's medications, I'm going to pull an API to get the side effects for those drugs, and then I'm going to look at the review systems, for example. We might want to expedite screening for clinical trials by pulling different data elements that meet certain criteria. We might want to scan notes for billing documentation and additional diagnoses opportunities. So the hospitals have armies of people looking at doctors' notes and looking at what's been billed. And if you work in the hospital, you as a physician, you will get a call saying, hi, I'm so-and-so from downstairs. Do you think maybe this patient would have a diagnosis of congestive heart failure based on your expert opinion? And you'd say, oh yeah, it's a good point, I'll put it down. And I'll say, great. Or I couldn't help but noticing that this patient complained of back pain the day they came in with their, severe septic, whatever. Don't you think you should also put down back pain as a diagnosis? And you'll say, okay, that sounds like a pretty good idea. What they're doing is they're not, upcoding illegally, but they're just making sure that everything that you're addressing in the hospital is billed for and charged for. On the flip side, the insurance companies want to make sure that you're documenting all the information so that you can only bill if you document that you looked at their back and you examined their back and you did all of that. So another thing that's done is people take the notes and say, do they meet the level of documentation? So a big area, and I'll tell you more about my meetings with the Cerner, head of FHIR Cerner yesterday, but many of the applications are around this sort of billing kind of work and how you can identify that. It's a major use case. So you might want to run predictive models that incorporate free text data. We've talked about many examples. I know, Jeff, with the Emory work that those guys are doing, how that will incorporate free text data in terms of algorithm development is phase one. But if they want to add it to, for example, a decision support or something that's going to happen at the patient level, FHIR would be a great way to do that. Quality metrics is another example. CMS says every year they send you a list of patients, like 600 patients, and say, we want you to, for these 600 patients, we want you to show us that they received beta blockers if they had a heart attack. And for these 500 patients, we want you to show us that they, if they had a ejection fraction less than 30, that they also were treated with this and that drug. And they have armies of quality research nurses and assistants read through the charts, document for Medicare, yes, we did it, yes, we did it, yes, we did it, and then they publish your performance scores. That takes a lot of time, it takes a lot of money, it takes a lot of work just to do that. So expediting things like quality metric evaluation is another one. So you can imagine, even though it may seem that population level, and of course looking also at adverse event reporting also is very key. But you can imagine population level things are the bread and butter, and you might think, well, why would I want to do something at a patient level when I can do it at a population level? Like, why would I even want to do that? Because I can get every patient. But the reality is that many use cases are for specific patients. They're for specific needs, for specific patients. They're on the fly at the point of care, and FHIR lets you build applications that integrate with EMR to answer questions more efficiently using tools, and in our case, like ClarityNLP, which I think would offer quite a lot of great potential integrated in. So that is my presentation. Are there any questions from anybody about ClarityNLP on FHIR as a concept or this initial implementation of it?
I mean, I can make some comments. I think there's still some work to be done. I'd be interested to, as we've talked about, meet with some of people who are actually doing this sort of chart review work and see what's valuable for Clarity to return in the user interface. So that kind of work, I think, would be valuable to add, and getting it working, obviously, and with Cerner and Epic, that would also be a good bonus as well.
And Cerner expressed yesterday their interest in having us be able to actually plug in with their system directly, like basically to be able to give us a Cerner instance that we could actually build like real stuff on.
Yeah.
Just to be able to demonstrate how show it in Cerner essentially, so that we can kind of convey some of that stuff.
And I think there's still the opportunity to really do the ClarityNLP Lite, so that we sort of don't have this entire underlying architecture that is ClarityNLP, works as intended for sort of this larger scale data that we use, that we assume, which is population level, but doesn't really make a lot of sense
for service,
for service, for stateless service. So I think thinking about and getting to a point where we sort of have a Clarity Lite, which just runs in a PQL, sort of a stateless format, would be very useful to develop.
I mean, I love the FHIR integration, bringing in that patient context. I feel like effectively doubles Clarity's reach, opens it up into a whole other world, which I was always in the population kind of mindset, but this really is other possible avenues.
Yeah, and in fact, that's a great point, Trey. So like the Cerner App Store, for example, or these these app stores, you can run. You would be able to run Clarity on any hospital that had a Smart on FHIR environment, which is pretty all the big ones, without them having to install the way, for example, working with Emory to install. They wouldn't have to install, but they could leverage these things downstream. So it opens the potential for a much broader user base. I talked to the folks yesterday about the Cerner App Store. They said they're starting to see a lot of traction, and they're starting to. We'll talk more about what they're doing, but they've got some number of applications that are in there, and maybe there's a few more. It's not yet hundreds, but they're growing the number of applications that work in there, and they're seeing health systems and so forth adopting that, and they really want to kind of work with us to get to a point of like zero friction setup, and I think that's why they were actually really intrigued by some of the stuff that we were doing, because and most of their work so far has been purely clinical. There's the clinical research part still evolving, I think, in terms of these integrations. So, well, thanks very much, Jeff. Thank you, and for coming on board. Any questions or any updates, Jeff?